Okay, welcome, folks. Onri Jay Benally in the shit. My name is Onri Jay Benally, and today we're going to talk about, a brief presentation, really, about low-cost demo qubits and resonators in Navajo. So we fabricated this in the clean room. So I went there with my mini team. So this is Mohammed, Miro, and Noah, who are studying under me. So these are kind of my understudies or my trainees in the laboratory, as I am a senior member here at the University of Minnesota, and we are funded by the Arizona State University Quantum Collaborative. Okay, so we are basically going to cover, let me see here, and some images of a one inch chip. So it's a silicon dioxide chip that is diced by hand, and then we use a diamond scribe. It looks like a pen with a diamond tip. And a diamond tip is just enough that you can actually scratch some area of the chip and then break it. You can kind of force it to crack. And when it cracks in somewhat of a straight line, and that's how you dice a chip. Anyhow, so the process that we use is actually based on a low-cost laser. The exposure process took about 6 minutes, which is actually really short compared to a lot of other lithography processes, like electron beam lithography, which takes quite a long time. So anyhow, there's no vacuum necessary for the process, which is great. And we use only maybe 2 or 3 layers of metal. And the cost is kept low in that regard. So it's what we call resource lean approach. And then the imaging process itself also uses the laser, and I'll show a picture of that really quick. And then basically, I trained my team on how to make photomasks or layout designs of the chip. Then we kind of went through the process of how it looks like. And then we went to the clean room and did some work. Because our research group is heavily focused on fabrication technology, and so we just have access to these tools. It is not expensive for us necessarily for something as small as this project. If we have bigger projects, well, I mean, that's part of our regular research. Anyhow, this is what a layout looks like. This is the chip that we made. It's very, very simple. The design is very simple as well. You have 2 resonators here, which is something you would normally see in a resonator design layout for any other kind of superconducting chip. So here, these 2 resonators, we actually could test these at room temperature based on the length of the wire or the length of the waveguide. These are coplanar waveguides in English. I will explain these terms in Navajo, so don't worry. We will get to the next slides talking about the Navajo explanation. So then here are 2 qubits. It's got a linear resonator. So this is a meandering waveguide. This has a linear response, or is designed to have a linear response. And then there are 2 devices here, which are designed to have a non-linear response. So you have linear resonator, non-linear resonator. And then here is an amplifier chip. It looks like a fishbone. So I'll show you what that looks like here in the next slide. So this is a picture of the chip. The chip has those same features that we showed, except this chip is fully fabricated. One and done. It's just a 1-step process, and that's about it. So here it says, so key word here is bitsira, means like the brain of a computer. So it means to think, or means to think, and then you can attribute the thinking to something by putting the I at the end. And then is like something that is fundamental. So you could use that in Navajo to describe a quantum object or some abstract thing that is quantum. And then and ni, it means something that is true, something that is real, something that is undeniable. And then besh it means metal. So you can put this together. This is a description in Navajo of what a processor is, a quantum processor. So this description here in the bottom that I wrote, it says, Akut ao, akun sohe. This means that there is a size about this chip, and that's what it looks like. So the whole size or the whole area of the chip that you're looking at, you can get a reference for how big it is. So that's what this says. To paraphrase it, Kunstsohe is like the whole thing. Means all together, and then let me see. The root word for a Kunstsohe is so. So let's see here. So means big, something that is large, or something that has a certain size that is relatively large. Or it could mean size in general, depending on how you use it. Normally, it does mean something that's big, but in this context, we're talking about the general area of some chip. And then here is a metric size marker, or should I say a scale bar, as we call it. This whole chip is actually about 1 inch across, to put in imperial units. So in millimeters, it is, let me see, a little over 20 millimeters laterally and also vertically. So in this direction and this direction, it is roughly about 22 or 24 millimeters or so, somewhere in that range, to put it in metric scale. Anyhow, you can see the features. So this is the microscope that we use to image the chips. It's got an optical microscope, and it also has a laser. So there's a red dot you can likely see on the screen. This tiny red dot is actually scanning back and forth very rapidly on the feature of the chip. And so if you want to look at the chip much closer in high detail, then this microscope is capable of that. And it's, again, a low-cost solution. The images are here. It looks very clean. It looks kind of like an electron microscope image, even though it's actually done by a laser. So this is a relatively new technique, but again, low cost. That is our aim. Low cost quantum education in Navajo. So let me explain this. I'll read it. It says, Besh Oze Be Nad Nishi. So it means a wire that we are using to do some kind of work. So you can think of this as kind of a circuit. So besh it means metal. Also means something that is small. So you can think, so in Navajo, this is what we use to describe a wire, a metal wire. And then be means by which something is. And then nal nish by itself means some kind of work or labor. So nav nishi. So by which the work is being done on the metal wires. Okay, the next section, I'll read it to you here. So the way I described it in Navajo is this. Besh aspoze achar naz nilagi akwe eya benzil achagi. So this means the metal wires that are sitting here next to each other are exchanging energy. So basically, benzil is like energy, and then achagi means that there is an exchange that is happening between the two, or between the things that you're pointing out. And then a coal, بأتنج إش بتزيد لنكي أثناء الداد إيكو benin na. So benin na means that is why. That's how it is. So akko means, and so here in this piece of wire, there is a charge current or electrical charge current. So limiki means there's some kind of current in here, like a river or like, well, you can use a current to describe a river. You can use it to describe whatever is flowing. And in this case, it happens to be electrical charge current. And that charge current or charge that is in this wire is sort of slashing back and forth. Atna'adat ego means that it is going back and forth. There's a charge that is moving back and forth. So it is, in essence, a high frequency movement of charge. And that charge is the reason why there is an exchange of energy between this wire and that wire. Because if you describe it using magnetism or using electromagnetism, you know, like Maxwell's equations, Maxwell's principles, ideas, and so forth. Basically, it's saying that as long as there's some kind of current that is flowing in a piece of wire, or if there's, in this case, microwave energy, you know, there's some charge induced here or charge moving here, then if there's a wire next to it, that wire will induce some more charge as well. And it's a carrier. So this is, so the energy that is flowing through these wire structures, these waveguides. I will describe waveguides in the next slide, but we'll slowly get there. That is actually, you know, performing a carrier of some wave of energy. Anyhow, so the next section says, Di besh atahas za shane eya bits amestoe bits the holongo benina. So basically it's saying here on this metal surface, there is a bunch of holes. So all of these holes on the metal surface, there's a lot of holes there. And the purpose of these holes is actually to prevent basically prevents a heat expulsion. So if there's any kind of, you know, charge that is moving back and forth here in this piece of metal, even though it is superconducting, if there's some really flat plane without the holes, what can happen is it can also induce a current inside of this area, this region here, where these holes are. And if these holes weren't there, then what would happen is it will start to induce these tiny little magnetic vortices, otherwise known as abrasive vortices. That's how we say it in English, but there is some result of that, and it is a tiny amount of heat actually starts to build up, even though it is supposed to be superconductor. And it hinders the superconductivity of this material as a result. So that's not good. And when the superconductivity goes away, and then there's lots of energy going on this waveguide, then, or electrical charge and lots of energy exchange going down the waveguide, then, you know, you're killing the superconductivity out here, and then it will start to produce heat. And you don't want the heat, because the heat will kill the superconductivity, and that's not good. So that's what it's saying here, is preventing the heat from generating in these local regions and that is solved by putting all these tiny holes there. That's what it's saying. in Navajo. So here on the right, it says, Besh oza be atilifish bedzid liniki a yisida bedzid. So this is saying that this is a superconductor. Here, this piece of wire, basically, it has the properties of superconductivity. There's a charge current that has a really strong flow of, or it doesn't have any hindrance. There's no limit. There's almost no limitation in terms of how much charge current can flow here, and thus it is a superconductor. This next section says, "Akodi a bitch ozla at eh." So bitch ozla means elbow. So this is an elbow of metal. That's what it says. And that's how we describe it in English as well. Yeah, this is a elbow resonator or elbow part of the chip. Okay, next section. Same thing, there's some work happening here using wires. And the description I put down here at the bottom says, Besh oza hiyad dolk ol nahalin do arje ndesh gish holon. So that means the wires, the metal wires that are here, basically look like a wave structure. It looks kind of wavy, like this. And so nahalin means it looks like that. That's how it looks. That's how it appears. And then do means and afanje. So it means that on either side of this wavy structure, there's a tiny gap. You can see these tiny gaps here, and so that gap turns this into a waveguide structure. And then the next section says, "Ako a bi badahon ego." So it's basically saying, and so here, this structure that you're looking at is a guide, is its own guide. So it's guiding something. It's guiding whatever signal that you want to send from here to here. That's how we describe a waveguide in Navajo. Next section. There's the word think again. So to think. Navnish means to work. Navnishi. So this is work that is being done. By which work is being done on the wire. So this piece of wire. So is thinking happening on the metal wires. So in this case, it is describing some part of the processor. Now, the next section here on the bottom says, Besh oza be navneshi do anje bebesh hidenez go nazbas. So let me read that one more time, all at once. Besh oza. Hold on, let me try it again. Besh oza be navneshi do anje bebesh hidenez go nazbas. So I said that all under one breath, essentially, in order not to repeat myself. Basically, this says that there's a metal wire that is situated here, and this is the work that is, the primary area of work that is used. This is this piece of wire here, and on either side of this, on the set of wires, which is the junction itself, there is a elongated piece of metal. Metal oval-shaped pieces. So that's what it's saying. There's metal pieces attached to either side of it here. And this is really just a literal description of what we're looking at in Navajo. But in essence, this is a qubit description. Okay. And then here's a picture of the chip itself taken with an optical microscope and a phone. So the scale bar's here again, and you can see the features a little bit more in 3D to some extent. So you can see the highlighted features here, the bright features that are reflecting. Those are reflecting because there's light coming from the microscope, and we're looking at it kind of at an angle. And this angle gives us a view of what those holes look like from here. And then it's a little blurry in the background because that's out of focus. And again, there's some bright highlights here as well. But to get a clear picture, we have these pictures already. And then if we want to put this in Blender, it is also possible. So you can take the picture, extrude some 3D object, and then project, or what we call shrink wrap, add a shrink wrap modifier, and then place the real image of the chip itself that we fabricated. You can see all the small scratches here and there, but the chip will still work. And there's the scale bar. So you can make this and use it as a figure. So it says here, same thing. Processor. And I believe this may be the second last slide. So it says here, Besh adits be just ahagi. Ba be nadmeshi. So basically this says that there is a metal that is able to listen, and through that, it is by which it is able to increase whatever it is listening to. So that's how we would describe an amplification mechanism in Navajo. And then this is being done by some wires here. So, besh, right here, metal wire. And then by which work is being done again. So there's some work being done here with some wires in order to amplify something, to give or to achieve gain, I should say. And then the description here, it says, Besh ya lo im nahalin. So basically this says that the metal wires that you're looking at looks like a fish bone. So hlo in Navajo means fish, and then bitsin means bone. You could also describe it as a rib in Navajo, but to make things a little less complicated and more straightforward and more practical, you can say bitsin. So bitsin means a bone. So this is not necessarily talking about the whole skeletal structure of a fish, but if you get the idea, a fish kind of has a bone or rib cage structure that looks somewhat like this. So nahalin is how it looks like. There you go. And so the last slide here, again, this is relatively short presentation. We acknowledge the Minnesota Nano Center for allowing us to use the clean room. I mean, this is a general acknowledgement. We do this acknowledgement for our research papers in general, but in this case, we used it to fabricate our chips. So we thought we'd put this acknowledgement here as it is relevant. So once again, thank you all very much for tuning in. Yeah. All right.